Have you ever looked towards a city skyline and saw a brown haze settling instead? Smog is a combination of ozone and other pollutants that settle at ground level. Today's lesson is how we can mitigate and solve some of the problems that are caused by acid rain. So, the old approach to acid deposition was just dilution. So, we would build tall stacks so that the effects of the pollution were spread over a greater area and became insignificantly small. So this typically did not work, but it did cause acid deposition to be deposited farther away. So now our newer approach is to reduce the emission of nitrous oxides and sulfur oxides. So here are some of the effects of acid rain. So it will dissolve limestone carvings as the limestone tries to buffer it. And one of the main producers of sulfur dioxides in eastern Canada for a while was nickel refineries. And this is the tower of the one at Sudbury. And it was so well known, it was actually on the nickel for a while. And this put lots of sulfur dioxides or sulfur oxides into the atmosphere, and it ended up destroying the ecosystems around Sudbury. So when we look at the precipitation of acid rain and the pH in different areas, we can see that, again, the Northeast United States, and this is similar to Ontario and Quebec in Canada, have lost the ability to buffer the acid rain in their soil. And so these are the areas that see the greatest environmental effects from acid deposition. And in Europe, we can see that this happens in Poland and the Czech Republic more than anywhere else. They're a high risk for the effects of acid deposition. And here we can see the effect of acid rain on a forest in Czech Republic. And this is similar to what was seen in Sudbury, where all of a sudden you had devastation where there used to be boreal forest. And in Sudbury, what they ended up doing was, after they were able to reduce the amount of sulfur oxides coming out of their smokestacks, they went and replanted the forest. So now if you drive by, you can see that all the trees are planted in rows. So some new technologies that are developed to clean up the emissions before they're released. One is electrostatic precipitators, which use electric forces to remove fly ash from coal-fired power plants. And the nitrous oxides and sulfur oxides can stick to those fly ash particles. So these are little unburned components. So we use electric fields to collect those precipitates and the nitrous and sulfur oxides. So sulfur compounds are common in some coal depositions, and some can contain more than 5% sulfur. But in Alberta, our coal is generally low in sulfur, so it does burn cleaner than coal found elsewhere in the world, which is why we also don't have as much of an issue with acid deposition, even though coal is our main source of electricity. Here's again how that electrostatic precipitation works. So as the electrodes cause particles to become negatively charged, they stick to the plates on the side, and will grab those precipitates in the emissions. Scrubbers can also be used to remove nitrous oxides and sulfur oxides from being emitted from power plants. And this is where the emissions go through a mixture of gases passing through substances that can absorb and separate the unwanted components. So here's a 360-ton scrubber that was used to help cut a power plant's emissions by up to 84%. Now, when we looked at old small power plants, the cost of adding scrubbers to them would make them too expensive to run. So we ended up shutting down old small power plants when the prices are low. So that we moved our power generating station to several large stations instead of many small stations. New vehicles also have catalytic converters, which removes nitrogen oxides from the vehicle's exhaust. And this is attached to the manifold exhaust before the exhaust goes out the back of the vehicle. So what happens in a catalytic converter is we take nitrous oxides and carbon monoxide and form nitrogen gas and carbon dioxide. And we can take hydrogen, carbon monoxide, and oxygen to make water vapor and carbon dioxide. So this is turning the harmful nitrous oxides and carbon monoxides into less harmful substances. Now, smog is also known as photochemical smog, and we can see this as ground level pollution, usually near larger centers. So now a major component of smog is ground level ozone, which is caused by photochemical reactions involving energy from sunlight. Now, ozone is really useful up in the stratosphere, but down near the Earth's surface, it's harmful to living cells. So photochemical smog can be formed through a series of reactions. One is the formation of nitrogen monoxide. Then in the atmosphere, that turns into nitrogen dioxide. Now, the energy from the sun will convert it back into nitrogen monoxide and then a free oxygen. And then that free oxygen is going to join with an oxygen molecule to make ozone. Now, this reaction needs to involve another substance like nitrogen gas to act as a catalyst in the reaction. So ozone is going to irritate and damage our lungs, which can cause premature death in people with respiratory illnesses such as asthma or cystic fibrosis. So it's very damaging to living cells. Ozone, incidentally, also inhibits photosynthesis in plants. And so that photochemical smog is often what we get air quality warnings about when there's an air quality warning, and they recommend that people stay inside or avoid extra strenuous activities, also from forest fires as well. So here is ozone when it's at 0 to 33%, 34 to 66%, or 67 to 99% as it's spreading over different areas. So another dangerous component of smog is peroxyacetyl nitrate, or PAN. Now, this is a strong irritant to the lungs, which results from a reaction of nitrous oxides with ozone and other volatile organic compounds, which exist as gases in the air, and the sources of volatile organic compounds includes gasoline solvents and other petroleum-based materials. So PAN becomes an issue when ethanol is used as an automotive fuel. So as a carrier, this is a carrier for nitrogen oxides into rural regions and causes ozone formation near the surface. So this is why rural regions can also experience ozone formation. So it's important to look for alternative energy sources to decrease our emissions of nitrogen oxides and sulfur oxides by decreasing the fossil fuel we need for fuel combustion. This will allow us to reduce our risk of acid deposition as well as climate change and photoelectric smog. So governments play a large role in preventing air pollution because they settle both domestic and international laws and regulations to help reduce the harmful emissions from fossil fuel combustion. I hope you enjoyed today's lesson. Take care.